The broadcast is now starting. All attendees are in listen-only mode.
Oh, goodness. Hi, welcome everyone. Of course, I pushed start the broadcast and I thought I was on my screen and it wasn't. So there we go. Okay. Welcome to our ICTM webinar for this month. Our topic this month is developing conceptual understanding in elementary mathematics. As I always like to do, I'm going to try to do some of my commercials sort of up front while I have a captive audience. So I wanted to acknowledge that these webinars are brought to you by ICTM, and membership in ICTM is what allows us to bring this type of PD. So if you are not yet a member of ICTM, we would love to have you join us. You can go to ictm.org. It's only $35 a year. It's quite a steal for all the things that you get. So here's how I'm going to kind of go through this beginning part here. I am going to introduce myself. I'm going to talk about the platform and how it works a little bit in case you are new to joining us for a webinar. I'll introduce our presenters and then I'll let them get started. So I'm Annie Forrest. I'm on the ICTM board. I'm 5/8 director, and I moderate our webinars. This platform works a little differently than maybe other webinars you've enjoyed. For this one, you are able to ask questions through the platform, but those questions go directly to me and nobody else that's participating in the webinar will actually see those questions. So feel free to be as candid as you'd like with your questions. There'll be a couple points during the presentation where the presenters are going to ask for questions, so be sure to go ahead and type those in. We also will have 2 polls at the beginning where they're like multiple choice questions that you can participate in. And if you have questions throughout, go ahead and just type those in. They come to me. I'll sort of curate the questions and give those to the presenters. And hopefully we'll also have some time for questions at the end. If you are participating live today, you will get a follow-up email tomorrow with a link to a Google form. You fill out that Google form for evidence of completion. If you're an Illinois teacher and you want that CPDU credit, or whatever they call it now, professional development credit, that'll get emailed to you after you fill out that Google form. Everybody will get a email tomorrow with a link to the recording and also links to any presentation materials or any resources that the presenters might share. I'll include in that email as well. So I think that's all of the sort of housekeeping items that I needed to share. As a reminder, just in general about webinars, if you go to ictm.org, we're having quite a collection now of webinars, having done this over the past 2 years. There's links to recordings of all past webinars, as well as links to register for upcoming webinars. Next month, we have a Desmos fellow presenting to us about using card sorts on Desmos. So if that's something that's interesting to you, you can sign up for that. All right, so I think I'm ready to introduce our speakers. So as I mentioned, our topic is conceptual understanding in elementary mathematics. We have Sara, Curran, and Jackie Murawska. Sara has been a 4th grade teacher for Community Unit School District 308 in Oswego for 18 years. She's passionate about math instruction and differentiating to meet the needs of all learners in her classroom. She recently completed her doctoral dissertation on the effects of flexible ability grouping in mathematics on intermediate elementary students. And then we have Jackie, an assistant professor of mathematics and the coordinator of mathematics education at St. Xavier University in Chicago, and she serves as the current president of ICTM. She specializes in teaching mathematics content and methods to K-12 pre-service teachers, and her research focuses on exploring ways to increase teachers' mathematical knowledge for teaching. So that is enough of me talking. I am going to go ahead and share screen here. Our presenters. Let's see here, sorry. And you guys click OK, and then we should be good. Perfect. Yep, we can see your screen and you guys still.
All right, great. Welcome, everyone. Thank you for joining us. I'm Sara Curran.
I'm Jackie Murawska, so thank you for coming.
We're going to get started with a comic. So this is sometimes what happens when there's no conceptual understanding that's existing in your classrooms. The students just feel like some sort of magic occurs, and then all of a sudden we have the answer to our problem. So we're trying to avoid this miracle that occurs in the beginning that ends up with us having a magical answer that they have no idea how we really got it and didn't really understand how it came to be. This is our agenda for today. We're going to start by talking about conceptual understanding and procedural fluency. What are each of them? What do they mean? And why do we need both of them for a great math experience? And then we're going to start by dispelling different myths that there are as to, well, do I really have time every day? And then at the end, we're just going to quickly share some manipulatives and how those can be used to build conceptual understanding. And then we will share some favorite K through 5 resources, different books that you can purchase that would help with building conceptual understanding as well. As Annie mentioned, we will take questions at different intervals throughout our presentation. So please feel free to type away as we're speaking with any questions that come up, and we'll pause to discuss those throughout our presentation. So we're going to start with a survey question, and we want to know, what is your current teaching assignment, just to get to know our audience a little bit better. If none of those fits your exact teaching experience now, maybe pick the one that you would like to be teaching in if you're a student, or the one that is closest to what you currently do.
All right, looks like we have about 84%, 88% of the people voted, 92. All right. So it looks like we have 30% of the participants, and by the way, we have 27 attendees right now. So 30% of them are K through 2 teachers, 39% are 3 through 5. We have 9% special education teachers, 22% are administrators, and 13% are university instructors.
Okay.
Welcome. Thank you.
Okay. Can you still see our screen?
Yes.
Good, because I want to make sure. So our theme today is conceptual understanding first, and then building procedural fluency after that. And what you see on your screen now is one of my favorite snippets from NCTM's book, Principles to Action, that came out in 2014. And if you look there on the top left, this kind of resonates with us most. And it says, providing students with opportunities to use their own reasoning strategies and methods for solving problems. So we want to make sure that that we can convince you that there's time to do these things, that if you, and to talk about the barriers that you might face that's preventing you from doing the conceptual understanding. And we hope that we make a convincing argument that if you just want to just give the kids a shortcut and show them procedures first, that this is not the right way. And we have some stories to go along with these dispelling of myths. So I need to take off, I think, our webcam, excuse me. Okay, so we can go to our PowerPoint. One moment. Still sharing webcam. We're attempting to advance our PowerPoint slide and having issues. Bear with us.
Try pushing escape.
All righty.
There we go.
All right, we're ready.
All right, so we're going to start by defining what are procedural fluency and conceptual understanding, so we understand the differences. Procedural fluency focuses on the rules, the algorithms that we give students or traditional methods even that we give students to move forward in math. And then conceptual understanding is really focusing on understanding the concepts. Do they really know what they mean, how they work? Do they see connections and relationships between different concepts so that they can really be successful in math? And really, we need both. So it's not that we only need one or only need the other. We do need both. But we're going to try to give some information about why we want to start with conceptual understanding first before we move on to that procedural fluency. So just a little more information. Kind of a nice quote is, when the why is clear, the how is easy. And so we want to make it as easy as possible for students by focusing on the why to begin with. And we want to make sure that they're not only learning procedurally, because that does not allow them to move forward in math and to really understand higher concepts of math. We want them to be able to totally understand it so that they can keep moving forward and even create math possibly someday. And then if students don't really have conceptual understanding, that's when you get some of those answers that seem really wacky and weird, that they just make no sense. So I think one that I see in my students a lot is that they will have a problem where it's obvious that they're supposed to be subtracting or taking away something, and they'll end up with an answer that's bigger than both the numbers that they started with. And sometimes if they only have procedural fluency, they don't understand that, wow, that makes no sense. I need to go back and try again and check my work. So we just want to try to avoid that from happening when possible.
So before we get into the myths and the stories that we want to share, which is the fun part, I want to share one example that Matt Larson had shared at the NCTM regional conferences in 2016. And I'm going to use some of his language. And when I work with teachers, sometimes they say, yeah, we're teaching all the concepts, and sometimes we don't realize that we're really focusing too much on procedures. And this is one of my favorite examples from Matt Larson. He showed this at a conference, and he said, let's think about what we talk about in the language we use when we talk about how to do multiplication of two-digit numbers. And Matt Larson says, okay, we do 3 times 7. It's 21. We put down the 1, and we carry the 2. And right there starts our lies of place value, because it's not a 2. We all know it's 20. But we say a 2, and then we say 4 times 7 is 20, we can add a 2. Well, we know that's not right, because it's really 40 times 7, and we're adding a 20. And then we put a 0, or we leave that space there, and then we start the next row. And there are so many things going on in the procedure that has a foundation in the concepts that if you don't do the concepts first, and you show the procedures, and then later try to do the concepts, the kids won't care. You have to do the concepts first. And so I'm glad to hear that there are some grades 3 to 5 folks here, because some of you might be using these instructional strategies. And I'll read the quote from Matt Larson. It is critical not to confuse instructional strategies intended to build understanding with end goals that include proficiency with traditional approaches. So as you know, if you teach these methods and help the students build these procedures, you hear from parents that say, why are you doing this? This is not the most efficient way. Well, we know, but what's important are the concepts, because the procedures will be forgotten. And the concepts really are what we're all about in mathematics in K through 5. So, I mean, this is not our main topic today, but you can see how the concepts and using the rectangular array model really lead to the place value understanding that we want. So that said, we have a second and last survey for you. And what we're hoping is that to bring out, what barriers do you face to develop conceptual understanding every day? Because what we hear from teachers, we're anticipating a couple of things, and we want to see if we're anticipating correctly and what other things you have to share. So we'll give you a minute to take this survey, and we'll let Annie tell us what you all have to say.
We have about half of the people voted so far, so I'm going to give them another couple seconds here.
Excellent.
Okay, we're at 80%, maybe a few more people. Okay, I'm going to go ahead and close. I actually think I can share the results. Let's see how this works. Oh yeah, look at that. Can you guys see that too?
We cannot, but I'm hoping the participants can.
The participants can. Okay, so I'll tell you what it says. So 38% of the people said it's too hard for my students. 67% said there's too much material to cover. 33%, I don't have enough time. 29% I have to follow my district's curriculum, and then 17% talked about the standardized tests.
Okay, and there is an open response, I think, or maybe we didn't put that in. Any open responses for that one?
We had to take it out because of the 5 limit.
Never mind. Okay.
Just kidding.
Well, good. I'm hoping what was an exhaustive list, but we hope we got the big ones for you. So let's talk about myth number 1. Developing conceptual understanding is too hard for my students. My kids need more skill building and aren't able to do these types of activities. So we have a story, and to frame this story, because I hear this all the time, they say, this is great, my kids can't do it. So we're going to challenge you to, every time you think about this, to give them a chance. And one thing that a lot of elementary and middle school teachers have a mantra is, I do, that means the teacher, then we do it together, and then we finish with you do, which means the students do some individual seat work. So I'm going to challenge all of you, when you're about to model something, can you flip it? Can you have the students do it first? Then you do it as a class. And then the teacher has the role of bringing together the mathematics. And it's harder, and it takes a little more time. But I want to share an anecdote that just happened, I think about 3 or 4 weeks ago, in my Math for Teachers course. So I teach a course for pre-service elementary school teachers. I have early elementary folks in there as well as the elementary. And if any of you have ever shopped at Bed Bath & Beyond, you know that these wonderful coupons come in the mail. We have one up here that says 20% off. And you should also remember that you have a $5 off coupon for $15 or more, and there's a $15 coupon, and there are constraints with all of them. So I give this task every year to my students, and I know this is a percent task, so this might not be for you kindergarten through 2nd graders, but the analogy is good. So I give this task along with the second task on a particular day that when we talk about ratio, proportional thinking, and percents, and the other one's about hybrid cars and gas mileage. So my normal protocol is, okay, I'm going to model the first couple steps. I'm going to give you a framework and a chart to think about this problem, and I give them lots of scaffolding up front before I set them loose. So 3 or 4 weeks ago, the reason I do this is I thought, well, we need a lot of skills to do this, and I was never confident enough that they had it at this point in the semester. And this time I thought, you know what? No net. I'm giving them the problem, no hints, no chart or anything. And it took longer than I expected. And as I walked around, I even saw some things that I thought, oh, this is not mathematically valid. Let's redirect them. So I let them all work, and at the end of about 25 minutes, everyone was ready to present. And in this particular day, instead of carefully sequencing which ones are going to go up to the front, I said, who wants to volunteer? And the table in front said, oh, I want to go. So I thought, great. So the girl goes up, and she starts doing the method that I thought was the mathematically invalid one. And I thought, oh, no, what's going to happen? And to my surprise, after doing this for many years, the same sorts of problems, it was valid. We had a lively discussion. And the moral of this long story is, it was one of the best classes I had this semester, in my opinion, because I let go. And I thought, I'm going to let him do it. And I drove home really happy that day. And it just shows that even if you've been teaching a while.
I'm doing a webinar right now. I'm not available. Sorry.
Sorry, guys. Yeah, it teaches us that even if you've been teaching a while, we have to say, I bet my kids can do this. And I was pleasantly surprised. And the more I do that, the more I'm convinced that I don't have to necessarily teach the skills first, that the concepts and the skills can be brought in together. So with that, what does this look like in your classroom? So we have a number of ideas that if you're thinking that I have to teach these skills first, maybe you can incorporate with some concepts. So I'll let Sarah share a couple more of these.
All right, so one of our strategies is to ask an open-ended question. Often we will ask questions or see questions in the textbook that look like this. What is 7 plus 3? Well, we can change that slightly to make it more of an open-ended question. So what are all of the pairs of numbers that add together to make 10? You'll notice that now there's more than one possible answer, which is really great because it helps the problem to now naturally differentiate for different students. One student might take the entire time figuring out one answer, but some other students might be able to come up with 2 or 3 different answers. And this allows you to change that procedural question on the left to more of a conceptual understanding question on the right. Here's another example. We often see these diagrams, pictures in our textbooks. We ask questions like, what is the perimeter and area of this rectangle? Fine, but more procedural in nature. So if we change it into an open-ended question, a rectangle has an area of 24 square centimeters. What might its perimeter be? They can try different strategies like drawing a picture, they can use equations, they might use manipulatives to try to find one or more than one possible answer for this. So just making that little tweak often is helpful to incorporate that conceptual understanding where it doesn't really take any more time than the original problem. We thought we would give you some other examples. The book in the bottom right corner, Good Questions for Math Teaching, is where the ideas for a lot of these questions came from, and we do have a reference for this book at the end of our PowerPoint, which will be sent to you with the recording so that you can look it up if you're interested, and I'll give you a minute just to kind of read down some of these examples. Here's a few more examples just to give you some more ideas.
I love the fish tank problem because they can get silly answers.
And then you see if they have conceptual understanding or not. All right, so those are some examples that maybe you can tweak for your specific unit that you're working on or your specific grade level. And again, that book has a lot of other ideas for K through 6 at least, if not 8 in it. So here's another strategy that you can use, and you can play what's called eliminate it. So I think of it as like Sesame Street, and I'm probably dating myself, but one of these things is not like the other. So these are actually 2 separate problems. So you have the box of 4 choices. So the top one, you would have 2, 8, 9, or 4 as your choice, and then a completely different problem that you would give to a different time would be the fractions that are at the bottom. And basically the goal is to figure out of these 4 choices, which one would you eliminate because it has a different characteristic. There's something that's different about it that would cause you to eliminate it. And what we do is we ask the students to list which one they would eliminate and then give a reason why they would eliminate it. And again, one student might come up with just one answer. I challenge my students that if they come up with one, to try to come up with either a second reason for the same number or to pick a different number with a different reason. So choose one of these 2 boxes, the blue or the kind of burgundy color, and we're going to give you just a minute to see if you can come up with which one you would eliminate and why, and if you have extra time, come up with more than one. All right, to give you some ideas, for the top one, you might eliminate the 9 because it's the only one that's odd. You might eliminate the 9 because it's the only one that's not a multiple of 2. You could eliminate the 2 because it's the only prime number. And my class will come up with things like, I eliminate the 4 because it's the only one that doesn't have any curves in it. Fine, great answer. Challenge them to see if they can come up with another one. And usually I pick ones that relate to whatever we're learning. So maybe I would choose this one if we're doing prime and composite. And if no one comes up with that suggestion, I might prompt them like, we're learning about prime and composite. Would any of these be eliminated for that? And that helps to kind of gear them toward what you're learning and thinking about as well. I also want to let you know that you can also put vocabulary words in here. So you could put in product, factor, quotient, and have them figure out which one they would eliminate from there. And you can also put shapes, geometric solids or 2-dimensional shapes in there as well, and ask for similarities and differences and which one would they eliminate based on that. All right, so kind of another little story here. Let's use the discovery method to find a pattern for operations with fractions. The discovery method is when you don't tell the students any algorithms. You don't really even tell them too much of what you're doing. You just kind of give them a question or a task, and you kind of say go and see where they go with it. And then at the end, you kind of guide them to where you want them to be if they haven't gotten there on their own. So my story is actually not from my specific classroom, but several of my homeroom students go and meet with the gifted education teacher for math. And one day they came back from math class, because we switched classes for math, and they were like so excited, and it was obvious they did something in math that really spoke to them. And it was funny because we were trying to do science after that, and the students who are like my best students, who never do anything wrong, they never get in trouble, that, you know, they do what they're supposed to do. And all of a sudden I see kids like walking around and they're like tossing notes to each other, and I have kids getting up to sharpen their pencil just so that they can whisper in their friend's ear. And it's totally obvious to me that they're totally talking about math, and they're trying to come up with a solution to this problem that she gave them in math class earlier, and their thoughts are totally consumed with it. So you know, I would like them to have learned science that day, but I wasn't going to say anything because they were so excited about figuring out the pattern for math. And so I went down to her after school, and I was like, what in the world did you do today? Because it worked, whatever it was. And she said, well, all we did is we were learning how to multiply a whole number times a unit fraction. So like 5 times 1/7. And she said, I didn't tell them anything about how to do it. I just said, here's a problem. What do you think the answer is? And they brainstormed and they talked about it and they drew pictures. And I think manipulatives were available if they wanted them. And they talked about how that would work. And then they said, oh, well, will that work for another problem? So then they did another problem. And then they started making them not unit fractions. So it might be 5 times 2/3. And she just said find a pattern. She never told them there was a rule. She never told them what the rule was, but having them do that discovery method. And I really believe that my students will really remember that for a long time, because they developed the rule, they developed the pattern, and I think it will really stick with them. So it was a great conceptual way for them to do something that a lot of teachers just automatically go to the procedural with.
Yeah. So on that note, talking about discovery method and whole numbers and fractions, I want to talk to you about the following problem. So on your screen it says prove 5 divided by 2/3. Thank you to Alan Zolman, formerly of NIU, now at Indiana, for this task. So I know that some of you aren't going to be teaching this if you're teaching kindergarten through 2nd grade, but I wanted to give you a problem for which, even for a grown-up, we have to think about it. So one more thing to preface this problem is that we want to convince you all that if you just do one task, take 5 to 10 minutes before you do a procedure, just like your math teacher had done with, you know, asking them these very good questions, it could make or break whether or not everything's cemented in with the procedures and the conception and the conceptual understanding. So here is your task to think about. If you happen to have a paper and pencil, you might, we'll give you a minute to think about it. You might have to draw some things. So the question is 5 divided by 2/3, what's the answer? Now, the assumption is you do not know the standard algorithm for this. So keep that in mind. And if you need a context, here's one to think about. Say the 5 represents 5 personal-sized pizzas. Now, I'm speaking for myself when I go and get those personal-sized pizzas like Lou Malnati's. They're still too big for me, so I'm going to assume that the 2/3 represents a serving size. So the question becomes, if you have 5 personal pizzas and a serving size is 2/3 of a pizza, how many servings do you have? So how many 2/3 fit into 5? So I'm going to give you a moment. I hope you think about this. If you have a pencil and paper handy, even better.
And we should say that if we did this with students, we would be giving them scissors so that they could cut out the circles, but obviously in a webinar, that's not going to be possible.
Right. So I'm imagining you're, having scissors and cutting things out. So let me give you just a moment to think about it. Now again, you don't have to spend 2 days doing these types of things, maybe just 1 or 2 tasks. So assuming that you all don't have pen and paper, we'll go a little quicker than we would in real life. And one of my favorite quotes I learned last year it has worked like a charm, is the following question. This comes from Edward Berger. He's a mathematician who's now the president of Southwestern University in Texas. To get my students talking, I always say, who is confident that you have the wrong answer? And I have the people who are never wanting to talk raise their hand up high and say, I'm confident that this is wrong.
And I just did this on Friday at an institute day with some teachers, and they were primary and they had done this problem, and they were totally willing to tell me that they had the wrong answer. So it actually did work really well.
I've been using it all semester, and it's wonderful. And it gets to the misconceptions. And so I'm hoping, in fact, in this one, that people have the wrong answer, because that's exactly what I'd like to happen, so that we can talk about why you think that. So again, with scissors, we imagine that you're thinking in 2/3, and I'm hoping that you can say the answer is probably going to be more than 5. And if we cut these out and rearrange them, you'll see that we definitely have more than 5 servings. In fact, you should see on your screen, I count 7. So some folks say, well, okay, that's 7 1/3. You know, there are a lot of things to talk about. So it's not 7 1/3, because the question becomes how many servings. So as you can see from your screen, if you have that little third of a circle sector sitting in front of you, you have half a serving as the person next to you. So the final answer becomes 7 1/2. And so from this task is how I build, what does it mean when we're dividing fractions? And how is it that how could it be that you get something bigger than what you started with? So this is what we mean by choosing one task and building some conceptual understanding, and then helping the students get to the procedures without just jumping to the procedures first. So this is the end of our long first myth, trying to debunk why skills don't necessarily have to come before concepts, and we wanted to open it up for questions that perhaps some of you were talking or typing to Annie before we move on to our other couple myths. And if you have anything else to add. So Annie, do we have any questions that have been popping up?
Yes, and if people have more questions, they can add them as we're talking about.
Sure.
But one thing that came up is, what do you do if parents are teaching the procedure at home?
That's a good question, and they will do that. And again, we still teach the procedures as well. It's not an either or. I still teach the traditional method in class. I try to use my mathematical language and remind the students that it's 20, like in the problem she did, rather than just 2, as we speak about it. But I do teach them the procedural as well for all of these, and we are advocating for that as well. We just want to start with the conceptual. So if they're doing that, that's fine. We just want to start with the conceptual so they understand why the procedural works. So I don't mind if parents do that, and if the students say, oh, my parents already taught me how to do that, I say, great, we're going to get to that, in a couple days, and then we start with the conceptual so they understand why it works.
Yeah, that's a good point. And to add to that, there was a school I knew of where they were using sometimes they call it the ladder method or repeated subtraction, to do division of whole numbers in 5th grade. And then in this particular school, the 6th grade teachers said, well, that's great that you learned that, but we're not doing that in 6th grade. You must use this procedure, which was the traditional algorithm. And similarly, I've heard similar things with using partial add-ins, the partial sums method for adding multi-digit addition problems in 1st grade, and then kind of forcing the kids to do a different procedure. So I think the big picture is whatever procedure, whether that's taught by the parent or by the student developed it or the teacher modeled it, whatever procedure makes sense to that child is the procedure that they should be using, even if it's not the most efficient.
Yeah, great. The other thing that came up, it was kind of a question. The example that you shared, or the routine you shared called Eliminate It. Somebody brought up which one doesn't belong. Have you guys had experience with that website, which one doesn't belong?
I think so, yeah. There's one that I just found recently that has that. So yeah, if that's the one that I saw, then yeah, there's a bunch of examples on there with shapes, with angles with the equations, with numbers that you can pull in there. They're already ready for you. So I think that might be the one that they're referring to. But yes, I did find one recently that had that, and I found it very valuable. So I would definitely recommend looking that up.
Yeah, I'll go ahead and put that one in the chat so people have that website.
Great, thank you.
Yay. Any more?
Nope, I think that's it for right now.
Cool.
Right.
So we're going to go on to myth 2. And if I remember correctly, this was the one that had the most, right?
Yeah, I think this is the one that I probably said and I hear the most at my building.
Right. So myth number 2 is I don't have time to focus on conceptual understanding. I have a pacing guide I'm supposed to follow with too much material to cover. We hear you. We've both been classroom teachers. I've taught middle school and high school, and the curriculum director or my department chair says, this is what you need to teach, and we need to get by this, chapter by this time, and we get it. I also taught at a small school in Bridgeview, where I had the same students from year to year, which means if they tell me I didn't learn this last year, I can say, yes, you did, because I taught you this, and I'll tell you anecdotally, and this is backed up by research, the times that I took shortcuts the year before and said, yeah, let me just show you this really quick. They don't remember it the year after. So we hear you, but we want to make the argument that it doesn't take that much more time to do the concepts first. A quick story that when I was teaching pre-service teachers, an elementary school teacher a pre-service teacher had to teach something that looks like this on your screen. 8 plus 7 equals and 6 plus 5 equals. They were given a book, and the pre-service teacher came to me and said, I'm trying to figure out how to show them how to put this on paper. And what the book was intending to do was, and those of you who teach at the lower levels, that they're trying to anchor to 10 and do the make a 10 strategy. So that we're wanting the students to say, 8 plus 2 is 10 plus an extra 5 can get me where I want to go. So oftentimes the conceptual understanding is in our books, but we might, as teachers, misconstrue that as, let me show them how to do it on the paper, but the thinking has to come first. So we have some just quick ideas if you're like, yeah, that sounds great, but how do I do that? Here are some ideas that maybe you're familiar with.
So another idea is to use a number talk. And again, we have the book in the bottom right corner. It's a great book that has all the strategies for you in order that will make sense for you and your students, with examples and actual questions that you can ask. And basically what it does is it builds up number sense and conceptual understanding by giving these strategies for mental math. So it actually has adding, subtracting, multiplying, and dividing in it. It has fractions. I think it has some other things as well. So you can really work on strategies for your level that you're working in. And what the students can do is they would have a task such as this. And what we would ask them to do is to come up with a way to do that mentally. And then they usually respond to the teacher with how they did it, and the teacher would write out on the board the strategy that they use. So it might be using friendly numbers or making tens if they're smaller numbers, might be drawing in a number line, thinking that way more linearly. And that you take all the strategies that the students give, and even if they give a more traditional method, that's okay, that's still a strategy that they can use. And by hearing about it and explaining why they did it that way and what they were thinking, it helps them to build that conceptual understanding. So we're going to give you just a second to kind of jot down on a piece of paper or just think mentally, how would you solve this problem in your head? And again, if a student finishes early, you can always say, hey, can you find another way to do this problem or to show this problem or to think about it? And they can add that as well if they have extra time. Here's one example of how they might do that. thinking linearly on the number line, adding 3 to get up to 40, and then adding your 10s, your 40 10s to get up to 80, and then adding the 5 more that are left to get up to 85. It's not the only way to do it, but it's one example of a way that might be shown in number talks and explicitly taught to the students so that they are able to think this way in their head if they are not already doing that naturally. Another strategy is to ask for multiple ways to do something, rather than just giving an equation and asking for the answer, asking them to show you in multiple ways. So for example, choose 3 ways to show me the product of 30 times 4. They could draw a picture to model that. They could write a word problem. They could show it on a number line. They could do just the procedural equation is fine. They can decompose the numbers similar to the one we showed you with the adding. Because this is multiplication, they could do a groups of or array model, or they could use manipulatives. And I like to give students choice. So say pick 3 of these to show me your product. They could just do one and you could share what different people did. But I like to challenge them to have to do more than one way so that they're really thinking conceptually about what that problem means. And also for more primary, you can also give them just a number like 6 and ask them, can you show me 3 ways, or well, I probably wouldn't give them choice in first grade necessarily unless they're high level learners, but say, can you use counters to show this problem? Can you use tallies? Can you draw me a picture? Can you mark it on a number line? And see if they can show those several different ways just to show a basic number. If it's, you know, a number in the hundreds place, you could maybe have base 10 blocks to show it, and they could write it in word form, and they could write it in expanded form, for example, if you're working with second graders. So those are all different ways that they can really show that they understand what this problem means or what the number means, to show that it's not just procedural, that they're understanding it. And so in answer to our question of how do I fit this in, some of our thoughts were as bell ringers, either when they first come in the morning, as kids are putting their things away, making their lunch count, they could be working on this maybe up on your screen or up on your board. We switch classes for math, so I often will post these in the front of my room as students are coming in, because sometimes the different classes get there at slightly different times, and they know that that's what they start working on when they first come in. You could have an investigation of the day that starts off your lesson. If you have stations or do small group work, often these can be something that they would do without you when you're not doing the direct instruction, and they could work in groups or in partners or alone to solve these. Definitely want to do it when you introduce a new topic to make sure they have the conceptual understanding of fractions if that's what you're starting, or of adding multi-digit numbers. You want to have them be able to start with that conceptual before you go on to the procedural. And then using manipulatives is a great way to model that. That doesn't take any more time. It's just a different way to show those same problems. All right, I guess we need to take, sorry. Annie, we'll pause again. Are there any new questions that you'd like us to answer?
No, nothing new has come up. Does anybody, if anybody wants to type them in, go ahead, but I think we're good.
All right, then we'll keep moving on and keep typing those in for the next time we take a pause. So here's another myth that comes up is I have to follow my district's adopted math curriculum. And people feel like they need to really stick to that. And as Jackie said earlier, most published resources do have the conceptual understanding built into their daily lessons, but sometimes as teachers we may read that and read it as a procedural task rather than as the conceptual one, or we might say, oh, I don't have time for that, and kind of skip over that part and get to a different section of that lesson. So that is, you know, sometimes an issue, but hopefully that the adopted curriculum already has that in there. But here's some ways that more traditional textbook type of question could be made into something more conceptual. So on the left, we're going to pull up what a textbook might say. Jan has 6 apples and Bob has 4 apples. Who has more? And instead, we could just add this part to the end. How do you know? Asking for their reasoning, proving their answer makes it more conceptual, even though we're keeping the exact same problem that we started with. And again, on the left, we do have the book where this idea came from. That's probably my favorite resource to use, so it's a great one to get. And again, the reference is at the end. Here's another example from the textbook. You might see something like what's on the left, making those comparisons. And all we would have to do to adjust it is say, well, do you agree or disagree with, and put in your inequality or equality symbol in the middle, and then ask them to explain their thinking. So it's still using the same problem, just asking them to defend their thinking. And then one more for you. textbook might say, what does 10 plus 4 equal? And all we need to add to that is, can you prove that, and ask them to do it without using numbers, because otherwise they'll tend to prove it with the procedural way of doing it. We want to see if they can use a more conceptual way to explain it, or to draw it, or to prove it in some other way with manipulatives or something like that. This one I really like to use in stations, is creating the word problem. So we might give them something like this. The answer to a word problem is 9 times 3 equals 27. So what is the word problem? I tell them, you get to play textbook writer, you get to play teacher, and you get to come up with the word problem now. And often with students, we need to model this the first couple times and give them some examples. But then they should be able to do it independently if you're giving them a problem that is within their ability level. Sometimes I just give them the answer. So 27 square inches, what might be the word problem that goes with that? And if it's square inches, then it's obviously going to have to be an area problem. So that would help them to have to think conceptually about what could have square inches. And then we also want to point out that for younger students, a picture is great. So if you say there's 2 toys in this pile and 5 toys in this pile, how many toys are there? You can just have them draw the picture of the 5 plus 2 equals 7, and they could draw the picture to show the toys if they want to make it toys, for example. So again, this naturally differentiates for students, but I found that even sometimes higher level students have difficulty writing these problems, or writing them clearly so that someone understands what it is they're trying to say, like might leave out units or something like that. So sometimes trading them with someone else and seeing if a partner can solve helps them to realize, oh wait, I don't have all the parts I need, and then can go back and try again. And it's great because this involves real world application. How would we really use this math in the future? Because they're coming up with a problem that makes sense. And sometimes you have to address that too, because they might come up with a problem that, yes, is a problem, but doesn't make sense for whatever the equation is. So you can have that conversation too about, does that really work and does that make sense? Have any more questions come up, Annie, before we go on to our next myth?
Just one question about kind of like plan time. So if you feel like, okay, you've convinced me I have enough time to do this in my class, but how do I have enough time to plan to do this? It seems, some people are worried like this seems like it's hard to do.
Totally get it. So some of the books that we've put on there, I find are really great resources because they have all the examples in them. And you can just take the examples right out of those books to do the open-ended questions, or to do some of these putting the practices into action, mathematical practices ideas. And they're also set up for different grade level bands. So you can pick what works best for your students. Even if they're not working on grade level, you might pull from a higher grade level band or from a lower grade level band to best meet their needs. And then sometimes you can take the idea and just tweak the numbers so that they're practicing the same idea but with different numbers. Like these word problem ones are really easy because you just give them a number that has to be their answer with units, or you just give them this equation and they come up with the word problem. The ask for reasoning doesn't take any more time for your planning. You just have to remember to say, well, how do you know? Or how could you prove it? Or do you agree or disagree with that? So some are maybe a little bit more labor intensive and thoughtful. With the great world of the internet right now, sometimes it's a little bit easier because you can Google it and find some more examples of these fairly easily. But a lot of them just take differences of wording, or just putting out this equation and asking them to show you 3 ways rather than 1. So hopefully some of these are, not as difficult to plan for, just because you're putting it more on the student to come up with the different ideas, like asking for 3 ways rather than with the same original problem. But I also like to really use these books as resources because there's so many examples that you can just take right out of there and hand to your kids, or just tweak the numbers slightly and use them in your class.
Yeah, maybe I'll add to that. Yeah. So really what Sarah's speaking to is, I think there are different levels of doing this. So first of all, tomorrow when you're in class, every time you go to ask a question, if it's a question that they already know the answer to, sometimes, and I'm going to quote John Benson, longtime ICTM member and Lifetime Achievement Award winner, he said, why would I be asking a question if they know the answer? So of course we're going to ask some lower level questions, for knowledge and on hierarchy. But so the one level of implementing this sort of thing is just every day asking yourself, can I ask for this reasoning? So it's in the moment teaching. Another level of like looking at a book or Googling things or going to NCTM Illumination site when you're looking for ideas, this might be not something that you can foresee doing every day, but maybe at the beginning of each unit. So you have to start small. And the thing is, you just got to try it. If you're thinking, oh, this is going to be hard, how am I going to know what they say? I know it. Give it to them. You'll be surprised with what your kids are going to do. And the third and last level is when we're seeking new ideas. I can't stress enough how important it is to get yourself out there at math teacher conferences like ICTM. If I hadn't been to math conferences every year to get these sort of ideas, I wouldn't have been empowered and confident enough to try these new things. So it's getting out there and talking with other teachers and saying, what are you doing? Oh, this works for me. Yeah, I'll try that too. You know, because it is hard, especially if you're like, well, this sounds great. I don't know if I can do it. You got to try it.
And maybe it's worth mentioning too, like when I use the putting the practices into action book, I usually pick one strategy like this, write the word problem, and we do it for the whole chapter. So it's not like every day I'm having to come up with something different to hand them. We pick one, we stick with it until they get really confident with it. So it doesn't have to be where every day you're putting in something different. If we do eliminate it as they come in and as like our bell ringer when math starts, we will do that one for several days because then they already know the directions and I don't have to take time to do the directions, and I just have to, you know, put some different numbers in each day. So once I've, you know, located that strategy, I can use it over and over for a while to make sure the students are secure in it. And then it doesn't really take me much more time to plan or much more time to teach because the students are familiar with it already. So I'm not mixing it up every single day with different things and taking the time to plan that. I'm picking one, sticking with it for the chapter, and then we move on to a different one.
Yeah, and don't get us wrong. I mean, we're not doing these awesome, wonderful lessons maybe every day, all day.
We just like to pretend like we are.
But we try, you know, and there are some days where I model how to do a problem. Now you try some, you know. But whenever possible, I try to flip it so that they're doing the work first and I'm asking them to build the procedures. So as often as possible. Was there another question before I go on to our last myth?
Nope, that was it. And I think those were great tips too. So thank you.
Thank you. So our fourth myth that we asked you about, that folks tell us, and we know, standardized testing is just around the corner. I need to focus on preparing my students for the test. I think we can all relate in some levels of administrators and pressure from many areas in order to get our students up to par. So I have a quick story. So the question I have on the screen is, do I need a shirt and pants to go to school today? So this comes from my daughter's experience, who is now 17 and a junior in high school. I will never forget when she came home in grade school and she said, you know, I didn't get what we did in math today. I said, what did you do? She says, I learned the thing where you can't go to school with just your pants and you can't go to school with just your shirt. You need both. And I thought, what are you talking about? I said, can you show me? Well, what she was trying to show me was her teacher showing them how to get common denominators when adding fractions with unlike denominators. And so specifically, she was talking about if you had to have 1/2, change it to 6, then you had to get an equivalent fraction of 3/6. She was trying to describe how you have to multiply top and bottom, the numerator and denominator, by 3 and over 3 in order. And that was the shirt and the pants. So the times 3 over 3 to make 1/2 into 3/6. And I said, oh, is that what you're talking about? So there was no mention of identity property. There were no drawing of pictures. There were no virtual manipulatives. There were no fraction circles. The teacher went and said, here's what we're doing today. Here's the procedure. And my daughter said, can you just, you know, show me how to do it? And of course, being a math teacher, I'm like, well, let's draw some pictures. Took a button. She was reluctant at first. We went online. We did some virtual manipulatives. And about 20 minutes later, she said, oh, it's about getting the size pieces the same. And she was speaking to equal partitions and getting the same size pieces. And so it reminds me of Angela Andrews' quote, another Lifetime Achievement Award winner, former kindergarten first grade teacher from Naperville. She said, teaching for understanding is teaching to the test. So if it takes a little longer to talk about the concepts, I am confident that we are teaching them to do well on standardized tests. And a note about manipulatives. Many of us have manipulatives in our classrooms, and maybe you haven't used them for a while. And we want to kind of remind you all that there are many wonderful ways you can use this to develop the concepts. And a manipulative, by definition, is a physical representation of a mathematical concept. And our tip today for you all is that we wrote the gradual release of the manipulatives is a bridge between conceptual understanding and procedural fluency. And what we mean by that is that the hardest part you have as being a teacher, I think you can agree, that is if you use, let's say, base 10 blocks to do addition and subtraction, we show the kids how to think about these, and what we don't want to do is say, okay, put those aside. Now let's do it on paper with no connecting the concepts to what we write on the paper. So if we had a long time with you, we have a long list of manipulatives that we can go through to talk about these, but we're going to be sharing these slides with you. So we'll kind of just go through our list quickly because I want to be cognizant of the time. I think we only have, what, 3 minutes left.
So here's just an example that you could do if you were using 1/2 plus 1/3 with your students and you would give them fraction circles. It's important to do that you do first, okay? Figure out how can we use these fraction circles to do 1/2 plus 1/3 and allowing them some time to figure that out. And sometimes they'll put them together like the picture on the left and you have to say, okay, great. But you can only give me one fraction answer. You can't say 1/2 and 1/3. So then they have to play around a little more until they figure it out. And that helps to build that understanding. And again, I would do several problems like that with just the fraction circles first. Then I would do some where they're doing the fraction circles and then we're checking it with the rule. And then I usually do some where we're starting with the rule and checking it with the fraction circles to make sure it works for all problems. And then we can move on to just the procedures and have these available if students need it for support. So this would be a way of showing how to make those common denominators similar to the pants and shirts one that she was just talking about. So as Jackie just mentioned, this will be sent out with our recording so that you can look back at these, but we have just a bunch of different manipulatives here that are typically found in classrooms or you can easily make for your classroom and all the different ways that they can be used. And a lot of them can be used for primary and intermediate uses that maybe you hadn't thought of before. So we're not going to talk about each one, but please look back at these and have them help you to maybe use some of the manipulatives you already have or can easily create in ways that are maybe different than you thought before or ways that you kind of forgot, oh yeah, I probably should use them for these different types of activities and concepts. So again, we'll send that out later so that you can really look through them and think about how you can start by using those manipulatives. It doesn't take any more time. It's just a different way of showing when you're first introducing a topic.
We also included our favorite books on these themes if you are interested, and we've put the resources here in this PowerPoint for you to look at. So in summary, we want to talk about the goal, and we have a picture to share for you. So I'll let you know.
All right, so again, the goal every day is to take a couple minutes to develop conceptual understanding first before you move on to that procedural fluency. Don't start with procedures, begin with concepts and thinking, and then move on to those procedures because that helps students to make sense of what they're learning and apply it later.
And here's a picture we found that attempts to sum up our webinar theme today. Mathematics with no foundation in conceptual understanding is risky. And when I say it's risky, we know that having procedures without the conflicts, without the concepts really undermines students' confidence, their agency, which is their willingness to take risks and engage in the mathematics. And we know from research that math anxiety can start as early as first grade. And we also know that by third grade, oftentimes math anxiety is fully set in. So we don't want that to happen to our students, and we are convinced that having mathematics make sense every day is important to our students, and the teachers have the power to make that happen.
Right, and then that's the close of our presentation. So are there any more questions, Annie?
And if not, I can also share here the conferences coming up in October. Here are our personal emails. So attendees can also email us after the webinar. We welcome their questions and comments.
And are there any other questions that we should address?
You know what? I think my microphone wasn't on when I was talking, was it?
Okay.
Right,
I'm
right.
like talking and
I
I'm
was
like,
worried we lost you for a minute.
okay, sorry about that. Yeah, no, I think we're good. I'm going to include your information there in the follow-up email so everybody has it. And then there'll be a short survey for participants, just giving us a little bit of feedback that we appreciate getting to make our webinars better. And I think that's it. So thank you guys so much. This was really helpful and a great webinar.
Thank you.
Thank you. Have a great night, everybody.
Goodbye.